a monolithic architecture or a microservice architecture, because there's trade-offs there. Then I'm going to talk about how an event-driven approach solves some key challenges that you have to deal with when you're building a microservice architecture. And then I'm going to finish up by talking about how Docker fits in and how it can simplify both deployment and development. So let's get started. So let's imagine that you're building a complex application, which probably almost everyone in this room is, right? We don't spend our time building trivial applications. And the example I like to use is an online store. And I'll show bits of the design in a moment. But I think it's safe to say that in order to successfully develop software, there are three things that you have to get right: the architecture, the organizational structure, and the processes that you have to use. There's a strong consensus around the idea of rather than having very, very large development teams, 20, 30, 40, or even more people, really what you want to do is break up your engineering organization into a team of teams. Each team is small, comprised of, say, at most 12 people, ideally just 6 to 8, right? Those teams should be autonomous, able to work fairly independently. And then there's also a lot of consensus to say that we should be developing using agile processes, right? Ideally, using continuous delivery, or better yet, continuous deployment. So that's organization, small, autonomous, agile teams who are delivering continuously. But what about architecture? So at a high level, there's two choices that you have to make. Am I going to build a monolithic application or a microservice-based application? So let's look at the monolithic approach. So here's my online store. And as you can see, it's both layered and modular. So there's a presentation layer that's exposing a REST API, but also generating HTML for the browser. There's various modules that implement different pieces of business functionality, like the catalog service, the review module, the orders module, and so on. So it's got a nice layered modular architecture. But when we use the monolithic architectural approach, we package everything up as the application, right? Just this big monolithic application. So in the Java world, that would be an EAR file, a WAR file, or a jar file. And there's analogous to packaging mechanisms in other languages as well. And the application uses the database. So, in fact, most applications I've built over the years have had this architecture. And there's a good reason for that. This architecture, or applications with this architecture, in the beginning, are pretty simple to develop, test, deploy, and scale. All our tooling is around building the application, testing is easy, and so on. The trouble that you have is that successful applications have a habit of growing. We don't just build an application and stop development. We continue to develop the application. So the team of developers is just making the application a little bigger every day, committing code, right? And you do that for long enough, in some cases 10 years. The other day I was talking to a client where they started selling it. They had a very successful demo. They started selling it, and 10 years later, they had an application that was 1.5 million lines of code. And the problem you have is once you have a large, complex application, any notion of being agile just goes away, as everything about developing and deploying that application becomes extremely painful. Also, from an organizational point of view, because everybody's contributing to the same code base, there's really no autonomy between the teams. The process of delivering or releasing an application involves complex merging and days of pain and so on. You end up in this situation that I call monolithic hell. And I'm sure some of you are living that every day because it's quite common. I feel like there's a certain inevitability that given enough time, your key application will become painful to work with. So what's the solution? Well, the solution, of course, is to use the microservice architecture. And what got me interested in this approach before the name existed, was I read this book, The Art of Scalability, which to me is a must-read book written by some architects who worked at eBay. And in the book, they have this three-dimensional model of scalability, another use of three. And so there's three different axes along which you can scale your application. So there's the x-axis scaling, which is where you run multiple copies of your application behind a load balancer. That's running multiple monoliths. There's z-axis scaling, where you're running multiple copies, but instead of it running behind a simple load balancer, it's behind a router that inspects the request and uses some attribute of it to route that request to a particular server. So in the database world, that would be sharding, where you use the primary key of a row to decide which server that row should reside on. Both x and z-axis scaling are all about monoliths. But what's really interesting is y-axis scaling, or in other words, functional decomposition. So that's where you break up your application, you break up your monolith into a set of smaller applications or services. And that to me is my definition of the microservice architecture, is functional decomposition. So when we apply that to the online store, we end up with an architecture that looks like this. So what were previously modules within our application now become standalone, independently deployable and scalable services, each one of which has its own database. That's a key attribute of the microservice architecture, which has a lot of benefits, but creates problems that I'm going to talk about in a little while. And then sitting in front of those services is the API gateway, which acts as a facade. It exposes an API that clients of those services use, clients such as a web application or a JavaScript client running in a browser or a mobile client accessed via a REST API. So that's the microservices architecture in a nutshell. And the nice thing about it is that it enables agile development and continuous deployment. It also enables the teams to act autonomously. So each team owns one or more services. They're able to develop that service independently, deploy it independently, and scale it independently. So it sort of fits very well with sort of modern organizational thinking, and also modern thinking around processes as well. So it's really good. And there's other benefits as well. It lets you much more easily adopt new technologies, because when you're writing a new microservice, you can pick a new technology at that point. You're no longer stuck with using the same technology stack throughout your application, which will become increasingly obsolete over time. So there are some drawbacks, however, right? And by far the biggest drawback of the microservice architecture is complexity. Things are sort of complex at this point. So number one, you're developing a distributed system. So what that means is that whereas before, when module A called module B, that was just a language level method call or function call, really, really simple development, you now have to deal with inter-process communication, which on the one hand, that yes, there are frameworks for doing messaging and frameworks for doing RPC, but it's just complicated, more complicated, right? Not only that, you have to deal with this concept of partial failure, which you did not have to deal with before. So in other words, when you call some other service, that service might not be up, or it might be really, really slow. So you might not get back a response ever. It might just sort of permanently hang. And you as a developer have to be mindful of that and have to program for that scenario. Also, as I mentioned, we've split up our databases, and yet we still have business transactions that need to maintain data consistency across those databases. And that becomes really tricky, especially because we can't use the traditional approach of two-phase commit. Distributed transactions are not a viable option for modern architectures. Also, testing is more complicated as well, because you might want to test a service, but that service could have a whole tree of transitive dependencies. Also, just deploying and operating your application is a lot more complex. Whereas before, there was one monolith, and you just ran n copies of it. Now there are